Alright, now let's begin our second section of the course, focus on data analysis. And in this section, we will explore two important Python libraries, Pandas and NumPy, and we will learn how to work with datasets, table, rows using Pandas, and we also use NumPy for numerical operations and efficient array processing. Let's begin with Pandas first. Let's open Jupyter Notebook, and now you're familiar that first you need to search the Anaconda Navigator, and after that you need to launch the notebooks, and it will automatically be open in your default browser, and you can navigate to your folders where you are working. And in my case, I'm working on the desktop, and the folder name was Python, and now I'm going to create a new file. And let's create a new Python file. And the first step is to rename your files, and because automatically the name will be untitled, right? And let's rename as Pandas. And here we need two external libraries. Okay, two external libraries. One is, by the way, we are working with Pandas, but we need NumPy because sometimes we have to deal with missing values, and there is a function that we will use there to deal with the missing values. That's why we also going to import NumPy. And the best practice is always to import in the beginning, because once you have these files on the top of your file, then you don't need to import again, because we have the reference and we already have included this file in our program. All right, now let's import that. So import an external libraries, the keyword we use is import, and we're going to import Pandas, and we're going to use an alias as pd. Pd is a short form, and it's an alias. So instead of writing pandas dot functions, we're going to use pd dot functions. The functions mean the methods we have inside this library, and that's the library we have. So you can use multiple cells, but it's your choice. So you can use multiple cells to import different libraries, or you can use the same cell to import libraries. So I'm going to import NumPy as np as well. So these two libraries we need for data analysis. So we already have imported Pandas library in our Jupyter notebook, and to import we use the keyword import, and the Pandas is a library. And by the way, once you have the Anaconda distribution, then Pandas library will automatically install there. And if you manually installing that, it will be a pip install Pandas, right? That's the command we use to install. And then we have import NumPy as np. Np is again an alias, a short form. Pd is common short name for Pandas, and np is we use for NumPy. Okay, so why we need, I already have explained you that sometime we have to deal with missing values. For instance, if you have a missing values that inside data frame, that is npnan number not available, I think. Let's see. I think that's the short form. Npnan stands for, it's not a number. Okay, that's the short form. That's the abbreviation of npnan. That's a NumPy. Nan number is not available. So in case if you have a missing values, we have to deal with that one. All right, now let's look at what we have inside the data frame. We have series. So in Pandas, a single column of data is known as series, and data frame is a combination of rows and columns. And a data frame is the most common Pandas object to use in data analysis. Okay, so these two concepts are again important, because most of the time we are dealing with columns, and those columns type will be of type series. Okay, and the data, if we have a data frame, then it will be it's an object, and it has rows and columns there. All right, so we have a data frame here. Let's first manually create the data frames, but you can also import files. I will import some files to explain this concept, that how can you also import external files. But let's try to create an external manually create a data frame first. So we are going to create sales data, and that will be a dictionary. Okay, that's a dictionary. Dictionary means that it has opening curly and closing curly bracket, opening curly bracket, closing curly bracket, and it has keys and values. And the keys we have is, let's say we have an order ID. Okay, that's an order ID. That will be the column name, and then we have some values there. Okay, and the next column will be separated with comma. So I'm going to put some few values. We have 2, 3, 4, that's a 6 and 7, and these are the order IDs. How many values we have? 1, 2, 3, 4, 5 and 6. And let's assume the next column name is, let's say we have is unit price. Okay, that's again a key, and we have a list of values. So you see we have, so we have a dictionary outside, and inside we have keys, and for the keys we use string values, and for values we using a list there. Okay, so let's put some prices, and that will be a 12, let's assume $12, $13 and $15 and 16, 17, 1, 2, 3, 4, 1, 2, 3, 4, 5, and that's the last one. So we'll just copy paste that data frame from the slides, but let me just explain the sentence. So this is, you can create so this is how you can create manually create a data frame. Okay, and that's the dictionary we have, and we're going to create a data frames that will be a sales, let's say sales df. Df is the most commonly named use. Df is stand for data frame, and but it's again just a variable. It's depend on you what would you like. So that will be a sales df, and that will be equal to, and we're going to use now pd is the alias we have here, and that is pd dot data frame. We're going to data frame, and it's in a class we have, and we're going to forward this sales data to this this class. And now we have a sales dm that we have a data frame, and we have rows and columns. And now if I print this one, you will see that we have indexes here, and these are the two columns that we have. So keys are used for columns, and these are the columns we have, and these values that are lists will become your rows. So we have two columns here, and we have how many values we have. So we have it, so rows start from index 0. So we have how many rows? We have 6 rows here. Okay, then there are a few important functions. Let me now just copy. So now I think now you familiar with how to manually create the data frame. Now let me now just copy the data frame from the slide, so we can now work on different other functionalities that we have in Pandas. So I'm now going to copy this one from here. So we have now order ID, we have region, that's a second column, then we have product, and then we have the fourth column is that units, how many units we have, and then we have unit price, discount, customer type, and corporate. So these are the column names, and then we have a different lists. We have values in the format of list, and most of the values are integer. These are integer values, and these are string values, and we will see that there are some function that also differentiate what kind of data types we have for these columns. All right, now let me paste this data here, and so you can also remove these cells by, you see that's the delete icon, because I'm not just going to delete that one. And you can also put some comments, like I'm just like to comment this cell, and now we do not have this cell. And now if you run this one and try to create that data frame, I think it will work. Why it's work? Because that value is already in the cache, and it's already in the cache, so we already have executed that, so that's what data is already there. So how you can remove that cache? So you can just go to the kernel and restart the kernel, and also yes, the clear output of all cells. This is how you can restart. Because now let's restart, and let me explain this concept again. So if you import this one, if you run this one, because that's already commented, it's not there. And if you run now this cell, now it's creating an error. The sale data is not defined because this variable is not there. Now let move this. So order is also important. This text should be above, not below. That should be here. So it's top down approach, and that would be sales data. Okay, so there is a syntax error. Syntax error is here. Okay, that's the syntax error. And there's also one space here because I just copied, and I think that space now will become a part of your values. So let's remove this space. So we have a lot of spaces for our string values, and there are some functions that we can use to remove these spaces. For instance, split, not split, I think it's not in my mind, but there is some function that can remove an extra spaces before and after the string, and but that's a very small data set, that's why I manually remove this one. All right, now let me remove this one as well. And there's one too. Oh, okay, so we have syntax error, means we have another error here. Let's remove that one too. Also, it's just a one-time effort, but because we are manually creating the data frame. Most of the time we do not manually create the data set, because we simply import files. Okay, importing files mean once you have the Excel file or CSV file, that will also be a data frame. Let's run this one, and now we have this data frame, and this data frame we have how many rows we have, and what is the shape. So there are some built-in function. Now we going to see those built-in function, for instance. Okay, but once you print out this variable, you will see that it will automatically print. If we have a limited row, it will show you all the data we have in this data frame. But sometimes we have maybe in thousands of record, then it puts some dot there. Okay, so it shows first few values, and also first few values from the beginning, and some values at the end. So there is a built-in function that we can be used. So it's a method that we're going to use. It's a head, and head takes, if you run this cell, it will now print first 5 values. Okay, it will print now first 5 values. Okay, but you can also pass how many values you need. Let's say I need just 3 values, so you can pass this an argument that I just need to show 3 values from here. All right, and let's say if you want to show 6 values, 6 values means 6 rows, then you pass, and this argument is a 6. So if you do not pass any value, it will take the default number, that is to display 5 values. All right, just no need to communicate. 5 values mean 5 rows. Okay, and then there is also a method that is used to display rows, that is from tail, as sales.ef tail, and now it will show you the last 5 values from this data frame. Okay, then there are a few other functions we can use. At this point, we're just exploring the data set that we have, and that will be a print. I'm going to use that the shape that would be a sale. What's the name of, we have sales. Okay, that's why it was not giving any hint, so it should be a comma. So that's a sales df data frame dot shape. Okay, so it will give you number of rows by column. Okay, so we have 8 rows, and the columns we have 7 columns, 1 2 3 4 5 6 and 7. Okay, and then we can also look at the name of the columns, and that's sales df dot columns. Okay, then it will give you the number of columns as well as their names. So we have these columns, and the column names are order ID, region, product, and you can also convert these column names into a list. Okay, that's again a method we have, that will be a to list. Okay, and now it will become a list. So we have, you see, now we have opening square bracket and closing square bracket. That's mean now it's a list mean that, let's say I need to print a region, that will be on index 1. Okay, that's your index 1. Because okay, Python is again a very friendly language that instead of saving this to a variable and then to print out values using their indexes, you can simply put indexes at the end here, or even you can use slicing here. You see now these are the two column names because we started from the first to the third up to third, not including the third. So we have now region and product. Okay, now the important one is to look at the data types. So we have sales, df, and that would be d type, d types. Okay, that's uh, we used to look at different data types in our data frames. So order id is integer 64, so that's an integer values. And then we have a region, that's an object, we have string values there. And then we have product is also string values. Unit, it's an integer value. And then unit price is also an integer value. You see that's an integer value. And then discount, that's a float values. You see that's we have decimal values there. And the last one is customer type, that is also an object. Okay, and then there is a built-in method that can be used to look at the mean, median, maximum, and also the quartiles. And that is that method name is that I'm going to use, that is sales df dot describe, and it will describe the integer values because over there we have min, max, and also the quartile values. So that's the integer columns we have, integer and decimal columns we have. And we have the count, total number of values, we have 8, and mean is 104. 104 is 600 is for unit price. And so it takes mean of all the integer values. Sometimes it makes sense for some columns and sometimes it doesn't, because we don't need to look at what is the mean of order id. But it's important here that for the unit price the mean value is 600. And the standard deviation, and we have mean 25 percentile, 50 percentile, 70 percentile, and the maximum value. Okay, then we can select one column as well, and we can also select multiple columns as well. But let's start with the selecting just one column to see what is inside that column, just in case we have to look at values there. And that would be sales df, and that would, and I'm going to select one column. Let's say the column name is product. Okay, that's the column we have. Okay, you see that space, do we have a space there? You see that's the space. I told you that if you leave this space here, that will become a part of the key. Okay, and that's why we have that space. Then you also need that space there to access this column. Okay, that was a causing problem. Let's remove this one, because I just noticed that we have a space there because it autofills, and that's why it put this space. So let's remove this space. So we have now these values there. And but you can also select multiple columns. For multiple columns you need a list there. Okay, that would be a list. And I'm now going to select multiple columns. That means that's the data frame we have. And now I'm going to put a list of columns that I need. Okay, that's a list of columns we need. Let's say now order id, order, and id. And then let's say the second one we need is product, and the third one we need is units. Okay, so now we just selected 3 columns from our original data frame. Then let's see what we have in the slides. Then so we can also import and export files. Okay, now let's try to export this data frame. So the function we use is to export file is pd is an alias, and that we get to CSV, pd to CSV, and the folder where you want to save this file, and we are right now we're working here. Okay, and the file name is here. So you can also create a new folder, or maybe just save inside this folder. It's your choice. If you have another folder, then you need to give the path of the folder. Let's say that folder name is data, and then the name of the file. Now let's save this to in the same folder, and the file name is, let's say, sales data.csv. okay, and index is equal to false. That I will explain later why I use the index false, because I don't need this column there when we save this file. So that's if you do not provide this index is a false, it automatically index will be true, and you will also see an extra column in your CSV file will be just these indexes. Okay. Module has no attribute to. Okay, so that's function name is not to CSV, sale df to CSV. Okay, what we are doing there? Oh, sorry, it's not a PD to CSV, it's this data frame to CSV. Okay, that's the data frame we have. And now you will see we will have a new file. Okay, that's the file we have. Okay, now that's the data frame. We have rows and columns, and you see that we do not have an extra column, that is indexes. All right, so this is how you can save files, but you can also import files in main, because that's the data frame that we manually created that one. But let's say you have an external file that we already know that we have few data sets, and those data sets are inside this data folder. Now I'm going to import this one, and that would be, let's say this is the df, and I'm going to pd read CSV. You see these are the multiple options we have. You can read CSV file, Excel file, then the other one you familiar will be HTML, JSON. So different files we can import. So I'm going to import CSV, and the file is inside the data folder. And if I use tab here, now it will give you the files we have there. And now I'm going to import, let's say, coffee. Okay, and now that's the df.head. Let's print out first 5 rows, and we have a data set here. So the idea of creating that to create data frame manually is just to explain the idea that if you have a dictionary, you can also make it as a data frame. But most of time we deal with an external CSV files, and we can simply import these files using PD, using Pandas, and that's the method we use, and we import that file, and now it's the data frame. And now let's look at the same methods that we already have seen. df.shape, and that will give you the shape that we have 3000 rows, 12 columns, and df.dtypes to look at different data types. We have object, zip code is integer, and rating is float 64. That means we have a scale from 1 to 5, but these values that we have are float. You see that's the 4.1 here. I think that's the column. Okay, all right, now let's look at few more functionality. Let's see what we have in the slides. So you can import CSV files, you can also export files, and these function we just have seen. Data types, summary, selecting one column, we also select multiple columns. Okay, so these two important functions are also sometimes we have to select rows using lock. We use lock is label based, and it can select rows and columns together. Okay, that's a label base. If you have a data frame where you have labels as a string values, then we use lock there. And when we use iLock is a position based. I also have another extra file that explains this one, because that's again an important concept in data analysis, and that file is, let me see, open it here. Okay, so that's the difference between lock and iLock. And now let's have this data frame and try to explain the difference between lock and iLock. Okay, that's the data we have, and now the df is this one. So now we have indexes as a string values s1, s2, s3, and s4. Okay, that's because we that's the dictionary we have, and then we forward that dictionary to data frame, and we use indexes. If you do not provide this indexes, then automatically those indexes will be integer values 1 0 1 2 3 start from 0. And so now we are saying the indexes are, sometimes you have data set like this, and we have indexes s1, s2, s3, and s4. And now I'm going to let's now look at the difference between lock and iLock. And if we lock, that would be df log.s2. s2 means that I need to print out this row. Okay, that would be df dot lock, and which row I need second row. Okay, this is how we select using label based rows. And this is in a series, because we so this is a series. Yes, that's also in a series. And we can look at the type. Okay, you see this is Panda code and series. All right, and you can also select multiple rows. Multiple rows means that multiple rows by columns. That now I'm going to select df. I need to select second row s2, and the column I need is let's say marks. Okay, mars. Key error means marks df. Oh, sorry, I forgot to enter lock. So that's this is how you can select df.log. And now s2 by marks. S2 by marks means that's the second row, and I said that I need marks, and that it print out 90, and it's saying it's np90, and np90 means it's an integer value, and if you use a print function, it will print out the value. That's a 90. Okay, that's a way of selecting rows and columns using lock. When you have labels there, and in case of integer values, for instance. Okay, so that's so you can also use slicing to select multiple columns, rows and columns. So s1 to s3, so that's when s1, s2, s3, and we have names and marks. These two columns we selected. And if we use iLock is used when we want to select data using integer positions. Okay, integer positions. So the data set we have string labels, but if you don't have string labels, then we use integer, and that would be df.iLock. And in this case we have iLock 1 of 2. 1 of 2 means that's because indexes start from 0, that's the first row, and we're going to select the second row. Second row is s2, and the second column means that because we start from 0, and that will be from here 0 1 and 2, and it will print 90. The same thing there. Okay, so that's the difference. So, and also few more differences we have. So you can look at this file on the canvas, and the simple rule is we use lock when we know the labels or names, and we use iLock when you know the integer positions. Okay, that's the idea of lock and iLock. And now let's look at what else we have in the slides. So now let's filter rows. That's an important concept. Sometimes we have to filter, we have to apply different conditions, and conditions mean maybe we need to select rows where rating is greater than 4.5. You can see these kind of scenarios on online sales. Let's you have a data where you have to look at the rows where rating was greater than 4.5. So now that's this scenario, this kind of use cases are known as filtering rows. And now So we now again going to use the data we already have that we manually created, and let's now remove these few cells from here. Okay, and you can use this cut icon to delete this one. And is it cut? Yes, cut. But you can also delete this from here as well. Alright, now let's run these cells again, and that's the shape we have, and that's this is how we can select single column or multiple columns. So at this point we just selected, we haven't saved this and we didn't do any change to the main data frame, so we still have the same data frame. And this explanation is just to select columns, but if you save it to the same file, same variable, then you will left with these 3 columns. Okay, now let me print again. So that's the data frame we have. And how can we select filter rows? Filter rows mean now I'm to want to select rows where region is south. Okay, and that would be sales. We have a sales df, and we want to filter where region is equal to, you can use single or double quotes, again very friendly, that would be south. Okay, so if you run this one, it will give you a boolean true or false. Boolean true or false mean it will give you true values where this condition is true, and false where this was we don't find these rows. And we need to use this masking. So this concept is also called masking. Masking mean now we forward this mask to the original df, and we can filter rows where these conditions was true, this condition was true. So that will be the sales df. Okay, that's the mask we have. And sometime we name it to as a mask as a variable, and then we save it there. Okay, that's the mask we have. And to have, let's say now we're going to have a filter rows equal to, from where we need to filter, we have to filter from sales df, and we forward this mask there, and we left with these rows. Because we let's also print mask so we can see where it was true. So the 5th row was true and the 1st row was true, so we have 1 and 5 left. Okay, this is how you can filter rows. And next we will see how can we use multiple conditions. Okay.